So one of the things that I teach my students about in my agricultural ecology class is how important it is not to till your garden area, your grow area, your large field that you might be putting corn, soy, and other things in. Now, there's a lot of misinformation out there about no-till, but there's also a lot of good information out there about no-till. One of the things about not tilling is that you keep the soil structure together instead of breaking it up and pelletizing it or turning it into tiny little bits. Basically, you destroy the aggregates when you till. What do I mean by soil aggregates? Well, if you dig a hole in your garden, you'll notice that the soil begins to turn into these little tiny clumps, and this is due to microbial activity, root activity, and insect activity, as well as worms and things like that. The worm poo, the fecal matter from all your organisms, the microbial organisms will grow different mats and in bodies under soil, and then the roots themselves will get in there and they will, through their activity, putting glucose down, creating little areas for microbes to grow, they create these little soil aggregates. And what's important about this is that allows water to infiltrate the soil. If you grind your soil up into a very fine powder, which is what you do when you till, what you actually end up doing is making it so that water can't seep into the soil, and therefore you spend a lot of money watering and watching your soil wash away during heavy rains and things like that. Well, to show you exactly what I'm talking about, there's a very simple lab that I do with my students that will show you exactly this. All you need is an Erlenmeyer flask and a funnel. And it helps to have some other things too, like maybe a coffee filter so you don't make your water all dirty and disgusting. And what you do is very simple. You grab some soil, or not some soil, you grab some cereal that will basically mimic your soil aggregates. Here's some Rice Krispies. And I add my soil aggregate into the filter there, and I add water. And what I'm going to do is sit here and I would time how long it takes for the 100 milliliters of water that I put in here to infiltrate through and down to the bottom. Now you can see this is happening fairly quickly. And this aggregate here is very similar to, the texture of sand, but it's pretty similar to the normal size aggregates you would find in your soil. Now, you could simulate heavier aggregates, bigger clumps and stuff using Cheerios or Frosted Flakes or whatever, depending on your soil texture and type. And you can mimic, essentially, the types of different soil that you may have. Now you can see I'm just about all of the 100 milliliters has gone through here. That was fairly fast, right? Well, if I wanted to simulate tillage, like what would happen if I actually tilled up the soil, well, what I need to do is destroy these aggregates. So I'll add my soil aggregate here, and then I'm gonna pulverize it just like I would with a tiller. So now what I've done is ground my soil, my Rice Krispies here, into powder, so to speak. I'll till it a little bit more. We like a really nice, soft, tilled soil. So you can see I have my nicely, finely ground soil, just like what would happen if I were to run a tiller through the garden. Now, I'm not sitting here telling you not to till the first time, because at some point in time you do need to get the soil in workable condition. So the first till is okay, but after that you should never have to till again. And here's one of the main reasons why you don't want to do that. So you saw how quickly the water went through the Rice Krispies. Well, take a look at this. So I'm going to add this water on top and see if you can tell the difference just pretty much immediately. I have to add it slowly because I don't use a coffee filter for this part of the test. And the reason I don't is the coffee filter will actually provide a path for the water to follow, and instead what happens, And you can see I'm about half of my water. I have to do this slowly because if I do it too fast, I will push all of the Rice Krispie treat into the jar. But you can see the difference. This is your tilled soil. And what I'm going to do is grab the camera and show you what's happening. So notice no water is getting through here. And this is not even 2 inches of soil. Most of your plants are going to be putting their roots down at least 3+ inches into the soil in order to get access to the nutrients it needs. Well, if you have very freshly tilled soil, nicely ground down into a dust, the water is not going to penetrate deeply into it. And eventually it will, but it's going to take a lot more water. And here's what happens. You can see the water just sits there on top. It has nowhere to go. And that is because all of those tiny little grains of the soil, the tilled soil, are now absorbing that water and also creating an impenetrable layer that it can't actually fit its way through. So you get this very slow percolation of water down to the root zone where your plants so desperately need it. Just to prove the point one more time so you have a good visual, here's normal soil with aggregates. And here's what happens when it rains. Right down to the root zone. So you can have little to no water getting where it needs to go. Also, as you saw, that increases the rate of erosion of your good topsoil because now all that water is sitting on top and washing away the very finely ground bits of soil. Or you can have good infiltration, and the heavy aggregates, the little tiny bits, keep the soil in place during heavy rains, so you'll get much less erosion. Which would you prefer in your garden? Do you want to replace all those nutrients and other things that wash away every year with your own expensive chemical fertilizers? Or do you want to have a good soil structure that encourages microbial life, worms, insects, and other things to feed your soil ecosystem, and have healthier plants as a result? You can throw money away, or you can let nature do its thing.